Good morning, everybody. How are you? Happy Sunday. So good to see you. So good to be able to spend this time together on Sunday. We're continuing our tutorial series, right? So I know that a lot of you get excited about Sundays. I get excited about Sundays too. I think we're going to have some really interesting discussion today. Today I think we're going to go over things that they simply do not teach you in most academic programs or most classes or tutorials or whatever nonsense you find online. I think we're going to do some really cool things today, so it's going to be fun. And also it's kind of fun because we're nearing the end of our series, right? We've worked our way through the series and we are, I anticipate that we're going to have today's session and then one more session next week, and that may very well be it. So I know that a lot of you just attend on Sundays. I know that a lot of you have attended every single Sunday. So thank you so much for that. Pat yourselves on the back. We almost made it. We just have one more Sunday to go after this one. And just really excited to see how everything is going to kind of tie together here at the end. I think it's going to be a really good session today. So for those of you joining us for the first time, you're also welcome here. Sundays, we do tend to go a little bit longer. We do a little bit of a series. So you're welcome to introduce yourself if you'd like, or you can just sit back and just watch. It's up to you. But today it's gonna be instructional. I'm not sure how much of the usual back and forth of questions I'm gonna do in the audience. But we'll see. We'll just see how things go. We'll have to kind of take things as they come and kind of go from there. But overall, I think we're going to have a good session and just really excited to get started. So go ahead and start filling up my chat if you'd like to say hello or introduce yourself or share something. But otherwise, we're going to get started here in just a couple of minutes because I don't really have a sense of how long today is going to take. I really don't have a sense for that. So we're going to have to kind of feel our way along and just see what happens, okay? So I'm going to finish up doing my final announcements here on Instagram. I think I need to put in one more. I need to put in the YouTube link. So bear with me just a bit, but go ahead and start filling out my chat. Let me know how you guys are doing, where you're checking in from. I'm seeing a couple of people on Instagram, which is great. But I don't see them in my chat just yet, in my chat window just. Let's see. Okay, so there we go. On Instagram, is it Lamia? Lamia, I think it's your first time, so welcome. Glad to have you here. I have posted the link to the YouTube view if you want to see a little bit of a widescreen view, but you're certainly welcome to stay on Instagram, and happy that you're here. I think there was one more Instagram message. Is it Malika? I think Malika on Instagram. Malika, thank you. Appreciate you being here. I think it's your first time. Same for you. You're welcome to stay on Instagram, or you can go to YouTube for a wider view. But yeah, welcome. Let me make sure I didn't miss any more on Instagram. Okay, that should be it. All right, so Osama, my good friend Osama from Satat says, hello, sir. Hello, sir. Happy Sunday. I hope everything is going well. Everything is going very well, Osama. I did a stream with you guys yesterday. We went 2 hours yesterday, which is not normal for a daily stream, so that was fun. Went out for a walk and then went out to get my groceries. Did a little bit of cooking yesterday, and just going from there. Woke up at 2 o'clock this morning. I've been awake since 2 a.m. working, looking at the materials. I didn't really share this with you guys, but it takes me a few days to put together the materials for Sundays. And the way I like to work it is I like to have my initial draft of, okay, this is what I want to say. And then I let it sit in my head. And then I come back to it and I say, oh, wait a minute, let me add this. Oh, I should have added, oh yeah, okay, let me adjust this. So the morning of, like today, when I wake up at 2 a.m., that's when I'm making my last edits. my final edits, you know? So I've been up since 2 a.m. I've been working on those edits, working on some other content for this week, working on some personal things. But I've been doing well. So hope the same for you guys. I want to spend the time with you, have this session, and then I have my soup cooking. I also, made my soup. I start my soup before the stream. So after this, I'm going to get my soup, watch my streaming shows. I'm watching Landman right now, and just relax the rest of the day. So it's gonna be a good day. Gonna be a good day. So thank you, Osama. Denelson, our friend from LA, says, very good morning, Dennis. Can't wait to work together with everyone today. Yeah, Denelson, me too. Like I said, I don't know how many questions I'm going to be asking today. Today is a little bit of a more unique session, but we'll see. We'll see what happens. I'll look for opportunities for feedback, obviously, of course. Starry Vibes, our good friend Starry Vibes says, hello, sir. I hope you're doing well. I am. Thank you so much. I hope the same for you, Starry Vibes. Lakshmi, our good friend Lakshmi, our good Sunday friend Lakshmi says, morning, Dennis and all. Hope everyone is doing great. Back again and all set for the next few hours. Next few hours, maybe it could take a couple hours. Who knows, right? Life is full of mystery and wonder, so who knows how long it'll take. I know you like the longer sessions, Lakshmi. But I tell you guys, these sessions wear me out. I intentionally start my soup before the stream so that I can do the stream, and then I'm exhausted, and then I can just sit there with my soup watching my shows and nobody talks to me. I don't want to hear anything. Just let me come back down and spend the rest of the day kind of relaxing. So Lakshmi, I don't know if you're gonna get a few hours out of me, but we'll see. But thanks for being here. Rex, our good friend Rex over on Twitch says, good morning, everyone. Good morning, Rex. Glad to see you here. Hope you're doing well. Hope you're ready for, the next installment in our Sunday series. I think it's going to be a good one today. Really excited about it. So I think it's Malika. I'm currently working on research project as my final year project in natural language processing. I do have intermediate coding skills, but need advice from you. Okay, Malika, happy to do that. There's two ways to get advice from me. One, you can come back during one of our regular streams. Sundays tend to be a little bit more of a tutorial, more instructional, so I don't really take a lot of questions on Sundays. Kind of interrupts the flow. So you're welcome to come back on any other of my streaming days. I usually I always take questions from everybody. I also offer coaching as a service. I do one-on-one coaching sessions where I do a lot of pre-work for our meeting, and then we have a meeting where I share some thoughts with you. I get some more information from you. We run through a couple of personal analyses that I then share with you. So you're able to book me with that. You can find the links on my Instagram, on my YouTube, and all that. So those are two ways, if you want some, additional, personal help. Okay. Ash, thank you so much for being a member of the channel. Appreciate your support. So glad to see you here. Good afternoon from South Africa. Nice. I'm getting quite a few viewers from South Africa. Yeah, really happy to see more viewership there. So hope you're doing well out there, Ash. I think we're gonna be in for a good Sunday session. Rex says, I'm having internet issues. Hope it gets solved quick. Oh, sorry to hear that, Rex. Yeah, we'll go slow, Rex. And if you need something, because you missed something, let us know. But as always, guys, for anybody who misses anything, you can see it on the replay. I archive all these live streams on YouTube. You can always find them there. Particularly for Sundays, I will edit them out. I will edit them to make them just a little bit more compressed, just for like the tutorial side. So you can always find anything you missed over there on YouTube. Okay. Let's see, Michael, good to see you. Michael's our friend from Lagos, Nigeria. Sunday blessings, Dennis and everyone. Very nice of you to say that. Thank you. Blessings to you too. I think we're in for a good Sunday, Michael. So hope you're doing well out there in Nigeria. Press skill? Is it press? Or we'll say press. Should I worry about words per minute as someone who's new to tech and has cerebral palsy? Excuse me. Gosh, that's a good question. That's a very good question. I'm going to say that I understand why you would ask that question. And I think that maybe there was a period where I would have told you that that would affect your work. But nowadays, with so much stuff being done by AI, I think you're going to be just fine. One, AI is much more about prompting, and you can write prompts at a reasonable pace, right? You don't need 90 words per minute to go to do a prompt, right? So that's going to help you. And the second part is that AI is also becoming much more voice activated, right? Or voice run. I'm sorry that I'm ignorant about cerebral palsy, but I'm going to assume that you could probably talk faster than you can type. So I think that's also something that's going to work towards your benefit, right? So you know what? I think you're asking the question at an interesting time, because I think that it's less of an issue now than it would have been a couple years ago. As recently as 2-3 years ago, right? So, Press, I hope that answers your question. If not, feel free to let me know in the chat, but let me know if that helps you. And also, Press, I see you're on Instagram. I've posted on Instagram the link to the YouTube session. If you want to watch us on YouTube, it's a wider screen. Sundays are usually easier on the wide screen. So you're also welcome to do that. Okay. All right. Press says, lol, yes. I'm assuming you're referring that to the speaking being faster than the typing. I think most of us can speak more faster than we can type, right? When I was doing the audiobook for my first year in data science, the guidance I had was that you can speak at about 100 words per minute. So that way you can kind of, gauge how long it's going to take you to record the book, right? So most people can't type 100 words a minute, right? Most people are under that. Even if you're fast, you're going to be like 80, 90 words a minute, right? 100 plus is like a whole other level. So yeah, you're probably somebody who can, talk more than you can, or faster than you can type. So I think you're going to be okay there, Press. Lawman says, hey, morning, Dennis. Glad to be back for the Sunday series. Hey, Lawman, good to see you. Lawman, I believe you're from Nepal. I believe you, so glad to see you. Hope you're doing well. I know it's a little bit late for my viewers in Asia, but I think the Sunday series is worth it. Well, I think every day I stream is worth it, right? But Sundays are definitely special, definitely more instructional. And like I said, guys, today's going to be unique. Today we're going to talk about things that you might not find a lot of materials on. I'm willing to say that you're probably not going to find a lot of materials on some of this stuff. So we'll see where we end up. Shiva, good to see you again. I think you were here yesterday. Shiva says, hi, sir. How are you doing? I'm doing well, thank you. How are you doing? Thank you for asking. So Shiva, glad to see that you're back. Today we're going to do our Sunday series, which is a little bit more instructional. I'm going to do my best to find ways to involve you guys and get more feedback, but I think it's going to be a little bit of a challenge today. That's what my gut's telling me. But who knows? Who knows? Another way I keep these Sunday series fun, because I was talking to you guys how I prepare the materials. Sometimes, when this happened earlier in this series, there's things that I want to say. There's messages and concepts that I want to get out, but I don't always know exactly how. And I don't always write them down in the slides. I just kind of generally in my head have like a path that I want to follow. And when the moment presents itself, I go ahead and, share different things with you guys, right? You guys don't always know that, but I'm just always thinking about it. So today's going to be one of those days where there's things I want to teach you. I just don't know exactly how. So That'll be part of the fun. It adds to the interest, right? So we'll see. We'll see. I remember you from last week. I think is it Smitter that you go by? I think you go by Smitter. I attend your Sunday sessions for the last 6 weeks. You have such an excellent communication skill, sir. You have great knowledge. Thank you for that. Well, that's pretty nice of you. Excellent communication skills. I'm okay. I'm okay. You know, the thing about communication skills, guys, is it's all relative, right? There's always somebody who's better than you. So I've been fortunate to work for some people with excellent communication skills, like people that I sincerely admire. So I'm okay, you know, but there are people out there who are very, very skilled communicators that I hope to be able to mimic one day. So, you know, I appreciate the compliment. I'm okay. But yeah, I'm still working on it. It's a process, right? There is no stop to your communication skills, right? It's a process. But I'm trying. You have great knowledge. You know, I'm just sharing my experience, guys, right? That's part of the entire goal here, right? I'm just sharing the stuff I've gone through. But thank you so much. Appreciate the sentiment, Smitter. All right. Anybody else who wants to share any opening thoughts or any other things before we get started? Omer, I think that's how you pronounce it. Omer says, happy Sunday. Hey, Omer, nice to see you. Omer, I think yesterday was your first time, so thank you so much for coming back. I love when people come back and reintroduce themselves and participate, so thank you so much for that. All right. Okay, so last call for introductions before we get started, because I think I'm just about ready to go here, so let me get all my stuff lined up. I'm gonna need that. Yeah. Okay. All right. I think we are set to go. All right, guys. So part 11 of our series. Thank you so much for staying with this series with me, guys. I know some of you have been here since the very beginning. So really glad that all of you are here, that you're getting something out of this. Today, we're going to be talking about a fairly unique topic. We're going to be talking about actually deploying to a server. And I'm going to show you how it's actually done on a real life server. We're going to go to a hosting provider. We're going to spin up a server. And we're going to start with a blank server. So this is something that I think there's not enough data science specific materials for this. So it's going to be a really unique session. I really think I'm bringing you unique materials here. But with that comes risk, right? Because I kind of know what I want to teach today, and I kind of know the steps myself. But we're going to have to feel our way along at some points, right? So I'm going to ask you to bear with me. Because in some of these points, it's going to be a little bit touchy. In some of these points, I might have to take down some screens, to protect my private information, because we are going to be working on a server. But overall, it's going to be a session where we're really kind of putting that final polish on your application, right? Because, we've talked about this before, in most classes, tutorials, whatever. You hand in your model, you hand in your code, you hand in your confusion matrix that displays your results, and the professor is looking for you to meet a threshold in accuracy or whatever, and then you're done, right? You're just done. Like you met the goal by submitting the final metrics, right? That's not the real world, right? That's not the real world. The real world needs you to use the program to do something, right? So that's why I think today is going to be really unique, because these are the things that, one, will really separate you over the long term of your career, right? If you can successfully deploy things. And two, this is the kind of stuff that I'm referring to when I tell you guys, when people come to me for work advice or interviewing advice, this is the type of stuff that shows that you're ready to go on day one, right? This is how you stand out. As I mentioned to you guys before, don't fall into the nonsense. Don't compete on the math. Don't compete on the code. Compete on you being unique and you being ready to go. Today's stuff is exactly what I'm referring to when I say that, right? Because this is the stuff that they don't teach you in school, that you wouldn't easily pick up, that you would kind of have to, kind of practice and do on your own, right? So with that said, let's take a look at where we're at. So if you guys have joined me before, it looks like I need to refresh this. Give me just a second here. There we go. All right. So if you guys have joined me before on a Sunday, this chart is familiar to you, right? So chat participation time. Where are we in this methodology? So I know there's plenty of you in the chat right now who've attended every Sunday. So you've seen the progression. Where are we in our progression right now? Now, I've already told you that we're kind of nearing the end of the series, so that should kind of help you guys out. But what do you guys think? Where do you think we are in the methodology? So I'll give you guys a second to think about that, but put your answers in the chat. In this chain of events here, where are we? All right, so Osama is deploy model, Michael deployment, okay. If you're shy, you can just say, hey, I agree with Michael, I agree with Osama or whatever. But what do you guys think? Where are we in this process? We've had two answers. Anybody else want to contribute? Denelson is one final, interpret results and deployment. Okay. Starry Vibes is also on deployment. Ash, deploy model. Okay, cool. Yeah, I mean, you guys are right. We're in the deployment phase, right? If you remember from last week, we basically ended up by saying, hey, we have version 1.0 of our project deliverable, right? So to refresh everyone's memory, we did a couple of things last week, but the biggest part of what we did last week was we modified our code, or rather ChatGPT modified our code via our prompts to say, okay, every time you find a champion model, which is to say a better model, save it. And then we asked ChatGPT to write some code to use that saved model and then create new results from that, right? And that is what made up version 1.0 of our model. Now, keep in mind, as I said last week, that is not the model training code. The model training code is how you get to a saved model. But then the saved model being consumed by your new code, that becomes your deliverable product. Right? Because the weights and measures that are contained within the saved model, or the weights and features, I should say, that are contained within the saved model is the product of our work, of our experimentation, of our champion model process, right? Our grid search and all that good stuff, right? But that stays with us. That stays within the data science team. The deliverable, what the client actually needs is to be able to use that model for forward-looking predictions, right? So we have that code and it's basically here, right? I'm gonna just quickly go over this again because I know we have a couple of new people. But if you remember, one of the first things we did when we kind of advanced a little bit more is we cleaned up our folder structures, right? We have a data folder, explorations, modeling, and predictions. The data folder is exactly what it sounds like, has a bunch of CSVs. The explorations folder is that initial kind of code testing and library testing that we did, to say, okay, that's a good idea, but is it viable? Can we get to a good piece of code with that, right? That was our exploration phase. And then we had our modeling phase where we actually had narrowed it down to the efficient frontier and the time series, right? And this is where we're creating our actual model. We have things like our hyperparameters located here, right? Which also makes up our grid search, which is essentially us running experiments, right? This is how you actually carry out experiments. And then that resulted in this function here, right? The fit function. And as we discussed, that's kind of like where the magic happens, right? When you have a fit function, you're basically saying, what is the best possible model for this? What is the best possible collection of hyperparameters that I can use to execute, to create the best possible model, right? As that code progressed, we were seeing these model results. So here's an example of one model that was kind of okay. We've agreed that the MSC is a good metric for us to look at, and then we can see the progression from model 4, it's a 10.9 MSC, model 5 is a 10.8, model 6 is a 10.6, and so on until we get to a model 9, that's a 10.5 MSC. So we've seen this progression, right? And then we end up with our predictions folder. And that's basically where we were working last time. And in the predictions folder is where we were able to say, okay, so this is the code, this is the actual code that we're going to be executing when we want to run a prediction, right? So very short and sweet code. It's under 60 lines, and it should be, right? Because at this point, we're not training. We're not running cycles. We're not doing Monte Carlos or epochs or anything else. At this point, we're saying this model file, the weights and features, the saved weights and features, is the model we want to go with. So go ahead and execute it and run and show me something, right? Show me a future looking prediction, right? That's essentially where we're at. So very short and sweet code, 60 lines, less than 60 lines. And really the key is here, right? That we're saying, hey, there's no need to create a new model. We have a saved model and I want you to load it and use it. Because that's kind of the purpose. That's in effect the deliverable that we owe to the client, right? Because that's what creates the future predictions. And that's ultimately what they care about, what your clients and stakeholders are going to care about, right? So that's where we're at. That's where we're at. So going back to the slides, this is good, right? But it's still running locally, right? We can keep things local for development, right? But for production, it's going to require a much more robust environment. And that's kind of the goal of where we're at today. We're going to get off the local machine and go to a production level machine, right? And if you do that, you've successfully carried out a deployment, right? All right, so here's what I mean by that. So we need to identify an appropriate server. We need to provision the server, which basically means prepare the server, right? If you guys have never done like server provisioning or permissioning, it's basically saying, let's set up the server in an appropriate way, right? We're going to need a virtual environment, but we already have an existing virtual environment, right? So maybe we should use that. Maybe we should copy it, right? And we can do that. You can clone virtual environments. And we'll talk about that. We'll talk about why you want to do that. And then you also need to replicate the files and folder structure, right? Because if you remember, our production code, or excuse me, our prediction code loads the model file. But this code here, this path, is dependent on the path that we have locally. So now we need to carry that forward into our new server, right? Because our new server is going to be blank, right? So we're going to need to do some basic like file structure creation, nothing complex, but stuff that needs to be done. So we're going to take on that. And then we're going to do tests, right? Because you need to make sure that the code up there is functioning as intended, right? So pretty straightforward, but these are things that have to be done in order to get you to a completed project. All right. So we can't have this discussion without talking a little bit about like server architecture, right? And a couple of caveats here with what I'm showing up on the screen right now. One, realize that I'm simplifying things just because of the confines of doing this on a live stream, right? I can't show you all 4 stages of the deployment, but I can show you at least one stage because they're similar to others. The difference will be the server specs and your ability to access those servers, right? And I'm going to explain that as we go along. So that's the first caveat I have to give you, right? That I'm going to simplify the implementation just to stay within the constraints of a live stream. The other thing you should know is that I'm laying out what is like a let's just call it like a generally accepted infrastructure, right? But there's a lot of variations on this, and it's going to be it's variable depending on your client, the enterprise that you're working within, what that individual IT structure looks like. Sometimes it can kind of be dependent on the size of your team. Do you have a small team? Do you have a big team? Right? So I'm going to walk you through this, but realize that there is going to be a lot of variance that, they aren't wrong. It's just the way your company, your individual client does things. And that's okay, right? There is no set in stone model for this. Okay? All right. So here over on the left, it's basically what we're doing. The local developer machine, right? That's what we've been doing. We are part of the data science team. We have our own local machine, local resources, and that's where we're putting together some code. And that's fine, right? In those stages. Next, you might be pushing that code to some sort of a team server. Because right now, we've essentially been working in a vacuum. We assume that this is the only feature, the only model that our entire team is working on. And that's rarely the case, right? You're going to have a data science team and then everybody working on completely different features or completely different models that feed into the same product. So you're going to want a centralized team server. It's still within the confines of your team. It's not a production level server. It's just a way to bring everyone together, everybody's features together, right? So that's kind of like your next step up. I have it locally because this is the project that I'm assigned to, but then I want to share it out with my teammates. I want to get feedback. I want to test the interactions between two new features that are being developed. So you put it on a team server, right? That's also where you might have like your peer code reviews if necessary or whatever the case may be. But that's your first step, to put it on a team server. Your next step is to put it onto a UAT server. Sometimes this is also referred to as a staging server. In some cases, a staging server is a whole other box, on my chart. So I have 4 boxes, but sometimes there can be a 5th box, and that would be somebody who has a separate UAT process and a staging process and then production. But for simplicity, I'm just showing the 4 boxes here. And you're going to hear this referred to as your user acceptance testing server, your UAT server, or your staging server. They're kind of, they kind of all do similar things. So what do you need this for? This is where you're sharing it out to people outside of your team. So this is where you do like your demos. If you have like a QA team, this is what they would use, or maybe not. When I say QA team, I'm talking about QA from your stakeholders. So if you want to get some feedback from your stakeholders, or you need human validation, you would do it against the staging server, right? You typically don't want to give a lot of access to your team server. That's why you have a separate staging or UAT server, because that's where outside users, stakeholders, human validators, that's where they should be accessing your application. So you're going to be setting them up on that, right? So if you're in a situation that has a separate UAT server versus a staging server, what's the difference? The difference there is that a staging server is intended to be an exact replica of your production server, but you keep it there to test things like new patches or new library installs, right? Sometimes you're replacing one library with another. So that is a little bit more of your like IT testing, right? It's more about making sure that the thing that you have the most production, the clone that is most like your production server, and that way you can run everything on your staging server and say, okay, if it works on staging, it should work on production. So it kind of gives you like a peace of mind ahead of time. But that would be the difference between that, where if you have a dedicated UAT server, that's where you're doing like your application level testing, right? Like I said, your human validation, all that stuff. And then your staging server is where you're doing more of like your IT testing. Typically, staging is not something where you would send a lot of users, right? Again, that's more for like the IT folks internally to discuss and manage, right? And then that's also, another item I want to bring up. You, as the data scientist, as the data science team, you're going to own the local developer machine. In most cases, you're going to own the team server. But when you start talking about a UAT server or a staging server, that's usually where the IT folks come in, right? Or a dedicated ML ops team, or whatever the case may be, a DevOps team. That's where your team kind of starts to lose a little bit of the control, right? I've been in some scenarios where we can write the code and the packages that we want to deploy, but we don't actually have permission, the necessary permissions to push them out to UAT or to push them out to staging. That's where you might have to hand over the code to somebody on your IT team, and then they take care of the staging side or those deployments, right? Same thing goes for production, right? Very rare to find a data science team that would have access to production. You're usually involving somebody else, an IT or DevOps or MLOps type of person to help with that. That's where it becomes a little bit less under your control, I put it that way because I kind of like having granular control over my deployments. That's just my personal preference. But some people are okay with just handing it over, right? And that's okay too. But I'm just kind of letting you guys know that that's kind of where it gets a little bit more serious in that way too, right? Because the IT folks are going to have their own policies and their own requests of you. This is where they'll give you feedback to say, oh, you're using Pandas 1.78 and we standardize on Pandas 1.6. Can you roll it back so that you use the same version we do, right? Like I've gotten that type of feedback, right? So that's where you kind of start to run into those items where you'll need to make changes, you'll need to pivot a bit, but it's not always about your model. It's more about like the infrastructure of making it work on their servers, right? And then also, a small difference to notice, I do say production servers because it's rare to find an enterprise that has just one production server, right? At minimum, you're deploying to multiple servers, if not multiple data centers, right? The bigger the company, the more data centers they're going to have, the more servers they're going to have, the more requirements they're going to have. So maybe it's not something for you to directly worry about. But again, coming back to the question of, well, why can't I use a notebook? Well, because you can't deploy a notebook to multiple servers, multiple regions in a very convenient way. I mean, if you tried to do that, it's kind of amateur hour, right? So that's the general chain that happens for a deployment. We are going to go, and by the way, I put these red arrows because the red arrows are basically the same. It's the same process that you're going to go through. We're still going to be following these same steps, right? Identify the server, create the virtual environment, replicate the environment we have, create the files and folders, smoke test. You're going to be doing that along the way. It's just a matter of which server you're pointing it to and whether you have the permissions to do it yourself. So we're basically going to do one of these red arrows. We're going to pretend we're going from local developer to the team server, but the process is the same, right? The process is the same. It's just that you may not be doing it or doing it against a different server. Or like I said, I need to keep it in the confines of a live stream. So what we go through today, it's the same process. It's just, a different server. Okay. All right. So I've covered a lot of stuff there. Are you guys still with me? Let me know in the chat. Give me some feedback in the chat. But this is kind of the goal of what we're going to accomplish today. Yeah. So I kind of have like this mishmash of things, like a potpourri of items that I wanted to get across, and I couldn't quite find a chart for it or like a convenient way for it. So I'm just going to put this out as a list, right? Okay, I'm getting some feedback in the chat. Thanks, guys. I'm glad this is making sense. All right. So I have this mishmash of things that I want to get across. And so we're just going to go down these one by one, okay? Number one of the things that we haven't really talked about so far is source control, right? And we have yet to have a session on source control, and that's okay. Source control sometimes, I think, can be a little bit overstated. People can get a little bit overboard with it. You can choose to do it on your local machine or not. It's up to you. But now, we are definitely entering a stage where it's more important, right? Because now when we're talking about sharing it from local to the team server and whatnot, now things get a step up in complexity. So this is where you'd want to start taking a better look at your source control, right? You can choose to use Git. You can choose to use whatever you want, really, right? There is no single answer to source control. But like I said, I really can't have this discussion with you guys without talking about source control. But when you're talking about going beyond your development machine, your local machine, you need to have some sort of source control discussion. Okay? You might have a formal QA process to go through. Now, as I mentioned earlier, when I say QA, because I know some of you work in QA or you've had experience, when I say QA, I'm not always referring to, somebody who's going to try to, find like a break fix to your application or whatnot. A lot of me is referring to your stakeholders and your human validators. Your human validators. There are plenty of situations where you will want to develop a script for your stakeholders, for them to go through your application and say, here, these are the features that we built in. These are the predictions we're making. Do you like the way a program is functioning? Did you click here and did you get their desired result? So that's what I'm referring to with QA, right? And in some cases, you're going to need that sign off to say, hey, I wrote this script for you and you told me you spent 10 hours and you gave me your signature. So to us, that means the model is working as desired, right? May not be making great predictions, but the model itself is working as desired. So that's the type of QA that I'm referring to. And this is where you would start to, push that out to your stakeholders, because QA from stakeholders always takes longer than you think it will. But this is the time for it. Okay. You might also have a formal model review process to go through. Depending on the company, depending on the size and the policies and blah, 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 they might have a model review process to go through. And I mentioned this in my book, Your First Year in Data Science. You can find it on Amazon, where that's something that nobody really talks to you about in academics, right? What the heck is a model review, right? So in short, model review is when a third party, a third person, group, team, whatever you want to call it, comes in and looks at your code. They look at your model, they look at your results, and they say, show me your training data. Show me that there is enough representations of the different classes in your training data. Show me that your training data is current. Show me the different experiments that you ran through. How many hyperparameters did you try? How long was your champion model process? Did you do it for a day or did you do it for a month? How many epochs did you run? So on and so forth. So they're basically like double checking you on how your model was built, right? So you might have to go through that, a formal review process, right? And it's very common that you can't proceed to production without getting their sign off, right? So you kind of have a third party that's a sign off. Sometimes that, the model review is going to be from the risk team, or it might be from the internal audit team, or in some cases, I haven't experienced this, but I have heard that they will bring in a third party, like an external auditor, to run your model review process, right? That's also a thing. How involved or how not involved that process will be is dependent on who you're working for. Again, it's client dependent, right? There's no single answer to that. In some cases, just to kind of put a final note on this, in some cases, this chart ties back to it, because one of the common tests for a model review process is, show me that your model works on UAT exactly as it works on your team server. So they'll ask you to deploy the model on both servers and run the same data sets and prove that you got the same result on both servers, right? Because they want to see that there hasn't been a loss between that migration from one server to another. That's a common request. So I'm just using that as an illustration of the kinds of things that might be asked of you in a model review process, right? So obviously really all the things on this page also have implications on your timeline, because now your timeline is affected by all of these, right? Your model review process may take longer than you think. In some cases, they may tell you the minimum amount of time that they need, and they'll tell you that ahead of time so that you can build it into your deployment process. In other scenarios, and the reason why I made this a separate bullet point is because there might be overarching timelines that you need to be aware of. So for example, in a lot of large organizations, they don't like to do deployments in December. They don't like to do year-end deployments. There's too much risk around that. So your last deployment of the year might be November. Okay. Well, your IT folks might also have their own process, right? Because if we just said that sometimes you don't have access to production, or you don't have access to UAT, only your IT staff does, Well, your IT staff may say, we'll deploy the code for you, but you got to send me your final package 3 weeks before deployment. Right? Like that's a common request because they want to do their own internal testing for the deployments. Because, you know, they're deploying it via scripts and stuff, right? They're not sitting there copying and pasting it. They have their own processes for it, right? So now IT is telling you you need it 3 weeks ahead. Okay. And then your model review team says we need a minimum of 4 weeks to review your model. Okay. So if you want to ship something at the end of the year, well, IT just said, nope, we don't ship anything in December. Our last deployment date is November 20th. Okay, but then they needed 3 weeks before that. Okay, so now you're in late October. And then MRM told you they need a month. So now you're in late September. So now, even though you might say, hey, I want to deploy this at the end of the year, your real deadline is September. You got to be done by September so that the model review can finish, that you can get it to IT at the beginning of November so that they have their 3 weeks to do their final deployment, and then you're done because nothing else happens in December. Like that's, you know, that's not an uncommon structure. I mean, I'm not going to name names about where I've seen that, but you know, that's a very common structure to have that. So I'm running you guys through that to kind of emphasize how important being aware of these timelines is. Because we're going to do all this in like, you know, a little bit of time here as far as the deployment to a server. But like in the real world, it like you have to plan weeks, if not months ahead of time to do the same steps that we're going to go through. Okay. So lots of things to consider when it comes to these deployments. Again, continuing like my potpourri of different items I want to get across to you. Data security becomes a heightened concern at these stages also. Because maybe before you were only working with sample data, or you were working with archived older data, right? Like maybe you were working on data that was in your data warehouse, but now you're going to be working on data that's production level. So your handling of the data and your team's handling of the data becomes very important. Your connections that your pipelines have are also very important, right? Because maybe you used when you're doing your work on your team server, maybe your pipeline was getting data from a backup, it was pulling from the backup Hadoop installation. But now when you move it to production, it's going to be pulling from the production Hadoop installation. So now you got to change that source, right? That source path. So you got to be ready for those types of things, right? You can't be hard coding these paths if you're going to be doing those types of deployments. So that's something you got to be aware of, right? Maybe the risks of your team having some sort of a data breach or some sort of PII violation, now it goes up also, right? Because now you're dealing with more sensitive data maybe in some cases. So overall, data security becomes a heightened concern the closer you get to production. And then for what I think is the fun part, this is also where you're going to have more presentations. You should be engaging your stakeholders a lot more and saying, hey, we're only a month away from production. Can we show you our latest results? Would you like to see this? Right? To Denelson's earlier point, yeah, you might have some visualizations to create at this stage. Right? Because you're not going to show them code, you're going to show them results in visuals, right? So this is where you're talking to maybe other data science teams, but most likely it's going to be other stakeholders or executives, right? To basically say, hey, this is what we've been working on for the past couple of months or whatever it is, right? So to me, that's the fun part, because this is your data science team's opportunity to show off a bit and say, hey, look, this is the result of our hard work. right? And this is the time for it, because now you're going to have it out there on UAT. You're going to have it out there on the staging server. You're going to want that feedback. Maybe you even, in the past, I've used these sessions as recruiting sessions for my human validators, right? I've done that where, I'll sit there in a presentation with like 60, 70 people. And I walk them through what my team was working on. And by the way, if you'd like to help us and be part of the process, you can be one of my human validators. Please contact me after this call and I'll get you started. And that's how you end up forming your last minute human validation team. Maybe your stakeholders, maybe you weren't getting the greatest feedback from the stakeholders, or the stakeholders tell you they need more people. That's when you do this, right? You get out there, you show your results, you recruit additional validators, make people feel involved in the process, which is important. But this is the time for it. In the greater stage of your project development, your methodology, this is a time for you guys to start showing off and saying, hey, look at this great thing we built. Right? So coming back to those communication skills, this is also the salesmanship or the showmanship side of data science, right? Like this is where you have to sell your work, right? This, building on our conversation from yesterday, this is where you tell the math PhD to not talk, right? This is not time for the math PhDs. This is friendly guy time. Hi, I'm Dennis and I lead the data science team here. And today I'd like to talk to you about this fantastic model we've been working on. We think it's going to increase sales 10% over the next 3 quarters. And I'm here to tell you why. Right? That's what you're doing at that time, right? If you put the math guy up there, nobody's going to show up for that meeting, right? So this is the time for it. This is the time to show off and start talking about what you've been working on. All right. So that, I think, ends the potpourri of the different things that I wanted to talk about. So now we're going to talk about the actual, I guess I don't want to say coding because we're not really coding today, but we are working with servers. We are going to work with Linux today. We're going to focus on Linux because I think it best helps us replicate a corporate environment, right? Yes, you're going to find Windows, you're going to find other installations, but for large, enterprise level organizations, they still use quite a bit of Linux. So it really helps to still know a bit of Linux. We're going to focus on DigitalOcean as our host. They have servers that you can very quickly spin up. That's why I like DigitalOcean. I'm not sponsored by them. I'm not telling you have to use them. I'm not telling you have to spend any money, right? Because don't feel like just because you don't have any financial resources, you can't learn. The reason I'm using them is just because they're quick and easy to use. But they're also a good way for you to practice your Linux skills if you want. And then we're also going to work with some virtual environments because they help us keep everything organized. We're going to use Conda as our environment manager of choice. That's what we've been using so far. There are others out there. I'm not trying to poo-poo those. I just feel most comfortable with Conda, so we're going to use that. And we have an environment, right? We have an environment that we're working with now, but we need to replicate it on a new server. So that's going to be part of the tasks. And then one thing I didn't add here is once we have that server, we need to start working on that server with Visual Studio Code, right? So one of the last things we're going to do is we're going to connect Visual Studio Code so that we can work with our new server out, our new team server out there on DigitalOcean, right? Because that way we can talk from the local machine to the server, right? So that's going to be one of the last things we do. I should have included it as a bullet point. I think I forgot that portion. But that's what we're going to do. So not a lot of modeling today, not a lot of data science code today, but this is a critical part of being a data scientist, right? Your model's no good unless people actually use it. And this is how you widen that access to all of your good work, right? So that's what we're going to do. All right, so let me quickly check the chat because I think we've gotten a couple of messages here. Tunga, nice to see you. Hi, Dennis. Learning hat is on, ready to go. Well, Tunga, today's all about learning, so glad you're here. Shiva says, today was a hectic day. Yeah, I know you're in India, so I know it's the end of the day for most people in India. But, you know, you can finish off your day by listening to your good buddy Dennis and seeing where we end up. Sarvesh, good to see you, my friend. Sarvesh says, is source control the same as version control? Yes. Yes, it is. Some people would argue against that, you know, and it's not a completely terrible argument. You could say that source control is more about your individual code, whereas version control is more about the entire code base and the different releases you're going to do, right? Because there is some management involved in that. But to me, it's all rooted in the same bucket of source control, right? This is our entire code base. We want to manage it as we go along, tracking the different versions, tracking changes, being able to see diff files, things like that. So to me, it is the same. You know, some people would tell you different, but I think you're okay thinking about it as source control and version control as the same thing. And also, you know, you could say that because there are some dedicated tools just for version management that are completely different from source control, right? Yassine says, hey, hello, sir. Late Yassine from Tangier, Morocco. Hey, Yassine, good to see you. Hope you're doing well. Is it Naaman? Naaman, glad you're here. I think it is your first time, so thanks for joining us. Feel free to participate as much as you'd like, or just hang back and, you know, watch the show. Manoj says, hello, sir. Manoj from Bangalore, India. Manoj, good to see you. I think we haven't seen you in a couple days. Hope you're doing well, my friend. Hope you're doing well. We missed you yesterday. You usually attend every day, but hope you're doing well. Naaman says, will this be a series or one-shot live stream? What? Come on. This is totally a series, right? You're on YouTube. Check out my channel. All of my series are on there. I have playlists for a lot of these series. But yes, this is part 10 of a series. So you're catching the late end of the series, but check out the playlist on YouTube and you can catch the whole thing up until today. And you can see the previous series and previous tutorials we've done. All right, guys. So let's get started. Let's start working on some of this stuff. So we're going to start in a web browser. I did not want... Nero Boy says, hello, sir. Abdullah from Nigeria. Nice. Welcome, Abdullah. Nice to have you here. I think it's your first time, so welcome. Yeah, glad you're joining us, and just follow along and let me know if you get stuck on anything. So we're going to start in a web browser. If you haven't used DigitalOcean, this is one of their initial login screens. DigitalOcean prepares everything by projects. So I've created a new project just called DSD that we're going to use today. And within each project, you're going to spin up servers. And in DigitalOcean, a server is referred to as a droplet. And that's what we want, right? We want one droplet that we can just kind of bang code against, right? And we're going to pretend that that's our team server that we're deploying to. But again, for all intents and purposes, it could also be a UAT server. It could be a production server. It's just us spinning up an external resource for us to work on. Okay? So this is the equivalent of a blank project on DigitalOcean, because there's nothing we can access, and the only options we have are to start things, right? So create a database, create a load balancer, so on and so forth. But what we really want to do is we want to click on here to spin up a droplet, because that's what we want to do. This is how we provision our server, right? So again, going through those steps, identify where we want it. We want it on DigitalOcean, and now we're going to provision it. So for example, here we're picking what data center we want to base it out of. For all intents and purposes, you can also pretend this is a list from a large enterprise you could be working for, right? A lot of enterprises have geographically distributed data centers. So you might work for a company that has a Bangalore, a London, and a San Francisco data center. That's not uncommon, right? So we're going to follow the recommendation to use a data center that's closest to you. So my closest data center would be the San Francisco data center. And down here, we are basically choosing our OS. Some of you might be more advanced with Linux than other people. That's okay. Go ahead and choose whatever you feel most comfortable with. I freely admit that I'm okay with Linux. I'm not great. I definitely wouldn't call myself great. I can hold my own. So I kind of like the plain vanilla OSs, because some of these OSs kind of get a little weird, right? They get a little out of hand. So I personally like CentOS. CentOS is kind of just like your classic middle of the road Linux install, right? It's not going to be too crazy. It's not going to be too difficult. It's just kind of a nice install. So personally, I use CentOS. I'm telling you that in case you want to develop your Linux skills, you don't know where to start. Look at something like a CentOS, or maybe like a Red Hat install, right? Red Hat can get a little bit out of pocket every once in a while, but take it easy on yourself. You don't need to know everything about Linux. You don't need to get crazy with it. Just start off with a basic install. So I like CentOS. That's my choice. That would be my recommendation to anybody who's new, but do as you like. CentOS happens to only have one OS to choose from, which makes it easier on us, or one version to choose from, I should say. So we're going to go ahead and work on CentOS 9. And then here is, again, provisioning. This is where we're choosing the specs. So obviously, DigitalOcean is a commercial enterprise, so they're going to give you a lot of options. But in your future career, when you're deploying this, IT might ask you, okay, what do you need? Are we talking GPU, CPU, a lot of hard disk, a little hard disk? What do you guys need? Being able to define that, very important, right? Not everything is a GPU problem. You don't always need a lot of storage. Sometimes you do, sometimes you don't. Do you need local storage? Do you need network attached storage? Cloud storage? You got to make all those decisions, right? Maybe not you in your first year, but your team as a whole will need to make those decisions, right? So we're going to go the cheap route, and I'm going to use their most basic server. Because again, I'm working within the confines of us here on the live stream. So we don't need to get too crazy with this. And, I need to sell you guys a couple more memberships before we can afford the big servers, right? With low key operation over here on this side, right? So $4 a month, or they charge you by the hour. So maybe you only want to get a server for a couple hours or for a week. You can do that, and kind of pay on a partial basis, right? But again, I have no affiliation with these guys. I just like that the servers are cheap and they're quickly accessible, right? I mean, we're going to start this server in just a couple of minutes. I mean, have you guys ever used AWS and tried to spin up a server on there? My gosh, it's so complex. To me, DigitalOcean makes it so easy, so straightforward. All right, so we're going to go $4 a month. And for that, we're getting one CPU, 512 megabytes of RAM, 10 gigabytes of disk, 500 gigabytes of transfer. That's reasonable, right? We're not storing a lot of data locally, so 10 gigabytes should be good. 500 gigabytes of transfer should be reasonable. Our data pipeline runs once a day to get the latest data. So that should be enough transfer for a monthly basis. And then that's basically it, right? We don't need additional storage. We have the option to add a volume, but that also increases our costs. We can do backups on here, or we can do our own backups, right? There's nothing stopping you from managing your own backups. And then authentication method, right? You can choose SSH or password, but the reality is that you might do a password just to keep things simple for you, if you're still learning or whatnot. But If you want to keep a more professional approach, you would do it via SSH. That's basically like a communication system that you can establish between multiple servers, and it usually works on a key pair, where you can say, this is my private key. I'm sending my authenticate information via that private key, and then the receiving server can use your public key to make sure that it's actually you that wrote that, so on and so forth, and that's how you establish a secure connection. So I'm going to choose to walk through SSH because I think it's the most secure method available. You can see that I already have my keys down here, right? I have the 3 different keys that I've worked with. So I'm going to go ahead and select all of those keys. And then that's it. You can see that the create droplet button has now become enabled because we've given enough information. And we have a name that we can give it. We're going to go ahead and keep that name. We could rename it to, to be the team server or something like that. But again, no need to get too fancy with it. $4 a month for a CentOS server. That's not the worst price in the world. Let's go ahead and click on Create Droplet. And it's spinning it up now, right? This is our server. It's starting it in the San Francisco location. And we basically wait. We wait for it to finish provisioning. This is essentially the actual provisioning process. Manu over on Instagram says, hello, sir. How are you? I'm doing well, Manu. How are you? Welcome. I think it's your first time, so welcome. All right. So now you can see that our project settings looks a little bit different because now we actually have something. We have a droplet, right? We didn't have that before, right? So now we have a droplet that we can actually work with. And we know it's a CentOS, and we could access it here. There are like little different console views you can, but the professional way to do it is to access it via terminal. And we've been using terminal this whole time, so there's no reason for us to not use terminal to access it, right? The key that we're gonna need is this, the IP address, because the IP address is what's actually open to the outside world. That's what's open to the outside world, ready for us to connect to. All right. So we're going to go ahead and copy that. And now we need to use our terminal to access this server, because otherwise it just kind of sits there with nobody accessing it, right? So let's start those steps. So this is the terminal that we've been using previously, right? This is we're in the folder. Let me just show you that, right? These are the same folders, the data, explorations, modeling, predictions that we saw in our Visual Studio Code. So this is the terminal in that folder. And you can also see that I've activated the alpha farming environment, which is the environment that we've been using so far. And that's good, but this is all local. So we need to start a new terminal window so that we can access our new server. So I'm going to open this up. I'm going to make this bigger. Let me know if you guys need me to make it even bigger than this. But now you can see that we're in a completely different folder, right? But what we really need is we need to get away from local and start SSH. So again, guys, I'm not an expert in these things, so feel free to seek out other tutorials. But we access it by SSH, and then the username we want to use, and then where the server is located, what server we want to access. So this is saying, I want to create an SSH tunnel, and I want to use the root user, and that root user is at this address. So take me to that server is what you're basically saying. And then because I already have my SSH keys locally, kind of baked into my OS, it's going to use those keys to go ahead and access that server. So the first time that you access any server via SSH, it's going to ask you to say, hey, is this the actual server you want to access? And here we're going to say yes, and we'll never get this question again. It's basically just asking if it's okay for you to get communication started from your machine to this machine. Here, this is asking me for the password to my SSH file. When you create an SSH key, you have the option of adding a password to that file. It's an extra security step. It's not required, but it's definitely recommended to add that extra layer of security. So when I type in my password here, this isn't the server password, right? This is just a password for my own personal SSH key to be able to say, yes, I'm authorizing this program to use my SSH key. So it's kind of like an additional layer on top of what's already an authentication method. So I'm going to enter this. Oh, I must have mistyped something. There we go. Okay, so now that I authorize it to use my SSH key, it took those SSH credentials, showed them to the server, and the server said, yep, you're the person that has access to the server. So now we're at a prompt. It looks like any other terminal prompt, but this is on that server, not locally. And we can verify that because you can see that this name here, CentOS San Francisco 3, is exactly the same name here, right? So it worked. We're at a prompt that now anytime we run something on this server, anytime we issue a prompt, the command is not local, it's on the server. And we can verify that because now if we give the same command as we did before, there's nothing in there. The server is completely blank. In fact, I don't think there's even a Python install. Oh, there is. Okay. There is a Python install, but it's 3.9.16. So in other words, it's a little bit of an older install, right? So this is the most basic install that came with the OS. It's not an install that was done by Conda or any other sort of package manager. So I'm a little surprised that Python's on here. I have worked with other CentOS instances where it's not available. You have to install it yourself, but that's okay, right? It just helps us reduce that one step, right? Okay, let me go back, check my chat. Okay, nothing in the chat. Let me go back to our list. Because this is the list that I told you would kind of be going through, right? So identify where the server will be located. We're going to use DigitalOcean. We're located in the San Francisco data center because that's our closest geographic location, right? So now provision the server, which we have, right? We chose CentOS. We told it what SSH keys are valid to use. And now we want to create a virtual environment. So what we need to do now is we basically need to do a Conda install. So just so you guys are clear, Conda is one of the most popular or common options for people working in Python. Conda is what helps you create those virtual environments for you to use. Why do you want a virtual environment? Well, because as you guys know, we do quite a bit of work with different libraries, different versions of libraries. Maybe you're just testing some things, kind of learning some things. If you didn't have a virtual environment, you would have a lot of collisions between versions, right? Where one version is incompatible with another, or said another way, you would kind of be locked into just a single library's version. You couldn't use two different versions of Panda or two different versions of scikit-learn because they're within the same within the same section, within the same environment, right? So the reason you create multiple environments is that you can have some explorations over here. You can have an older version of pandas here while working with a newer version in this other environment. So it kind of creates silos that don't cross each other and kind of help keep you safe and kind of help keep you working in a way that isn't going to cause versioning issues. So in this previous terminal, or excuse me, in this other terminal window where I tell you that I've activated the alpha farming environment, this is the environment that contains our pandas, our profit install, everything else that we've done from a library basis. It lives within the alpha farming environment. So that's the environment that we want to replicate on the new server. But we can't do that until we've also installed Conda, right? Because Conda is kind of the overseeing manager of that. I don't think Conda is installed here, but we can find out. Yeah, so there we can verify Conda command not found. So in other words, there's Python on here, but not Conda. So we need to walk through a Conda install to be able to do this. Not difficult, but you know, it's not something you have to do every day. So I can kind of muddle through the commands for getting a Conda install, but why do that to ourselves? We have an employee, right? ChatGPT. So let's start. This is where we're developing more of our prompting skills. If you need me to zoom on anything, let me know. Okay, I think that's a reasonable prompt. So remember, guys, this is Linux. So this isn't like Windows where there's an exe and you download it and you execute it. Linux tends to be a little bit more command line based. So there is a command line install for just about anything you need in Linux, right? So that's why I asked it for a command line prompt to install it. So first thing it's doing, it's going to ask us to update Yum. Yum is a common program to help you with installs of any kind, not just Conda. And then it's saying that this is the command for me to go out and get Conda. Curl is a common command. It's a command that basically goes out to URLs and say, get me a reply from this URL, right? And then here we can go ahead. Well, we can verify the command. It's going out to the Anaconda repos, which makes sense. It's getting us mini Conda, the latest install for Linux and for the x64 machines, which is what we need. We can do a verification here, which is optional, but you know, usually a good idea. And then this is the actual install. Bash is considered one of the scripting languages, I guess you can say, or scripting programs that is common in Linux installations. So we're going to go ahead and execute this sh file, and that sh file is what actually puts Conda into our OS. This is kind of like the exe command equivalent that you would use in Windows, or this is like when you double click on the install icon in a visual OS, right? That's kind of the equivalent there. And then we're basically done, right? We're going to go ahead and activate it and initialize Conda, and then we're going to go ahead and restart the shell. So that way it takes in it recognizes Conda within the within the, I can't remember the name, within the shortcut files of Linux so you can easily refer to Conda, and then we're done, right? We can use Conda just as we would in any other instance, or really just the way we've been using it to date. So to me, all of these steps seem pretty reasonable. So I'm going to go ahead and start executing some of these. So the first thing we're going to do is we're going to update Yum. And it's really no different than the other things we've been doing. We literally just kind of copy and paste to what ChatGPT shows us. So here you can see that Yum is updating 260 different packages. It's a lot, but that's not unexpected for a brand new server, right? By the way, if you guys want to sound really fancy, you know, with like the IT guys, you know, you want to sound like you know what you're doing, this is referred to as a bare metal install. Well, actually, I guess some people would say bare metal is before the CentOS install. So you could refer to this as a bare metal install, or maybe like a hardening install, right? If you want to sound really fancy, because that's, you know, that's how the IT folks refer to it. All right, so this one is a little bit of a longer process. Is it Gautam? Gautam over on Instagram says hi. Hey Gautam, how are you? Welcome. I think it's your first time, so glad you're joining us. Lots of new users in the past couple days. Yesterday we had a ton of new users, which is awesome. All right, 20 seconds ETA on this latest process. I'm going to start prepping the next command we need, which I believe is the curl command. Yep. All right, so 260 packages have been updated, including some Python packages, if you see over here, which is nice. So the previous run was the downloads, now it's actually doing the installs. $507. Wow, that's a lot. That is a lot, but needed, right? While we wait for this is a great time for questions or a great time for introductions. If you're joining us late, that's okay. We go longer on Sundays. So feel free to ask questions or introduce yourself. It's up to you guys. But we're gonna be here for a little bit. We're on 161 of 507. So this is gonna take a while. So I get it, guys. Not a lot of data science today, right? But what do I always tell you guys? You got to be flexible. Don't think of yourself as just a data scientist. I only do analytics. I just do visualization. You're a data professional. Knowing how to manage your own servers and properly share your code out with other people, other teams, whatever, is part of being a data professional, right? This is part of the process. You should know how to do this. Maybe you won't have to because you'll have a dedicated IT team, but it's valuable. It's still valuable for you to know this. It's valuable for you to be flexible and say, oh, hey, the IT guy is out on parental leave this month. So, hey, I can do the install. I've done that, right? So it's good to be flexible, guys. All right, we're on 499 of 507. And now we're on the last one. I think this one might take a little bit because these are the actual kernel cores. Naaman says, do you think in a few years Gen AI will be a requirement for data scientists? In a few years? I think it's a requirement now. No, I think it won't be a few years, Naaman. It'll be sooner than that, and we will be heavily aided by AI, just like we are today, right? We could have gone to the Anaconda website and seen what the latest release was and this and why? We can use ChatGPT for that, right? So we're already doing that. So Naaman, I know it's your first time, but when you look at the series on my YouTube channel, you'll see that we've done a lot of code, a lot of operations without writing any code ourselves. We've been using ChatGPT the whole way. Like ever since I started doing these live sessions, like back to July. So yeah, July. So yeah, it's already a requirement for you to have some prompting skills and some knowledge of how to use AI in your daily work as a data scientist. Absolutely. So it looks like this is the last install, but it's taking a little bit of time, and that's okay. All right, this shouldn't take much more than a few more minutes, but let's see what happens. Okay, it looks like we had one failure of Cockpit WS. I can't say I'm familiar with that particular one, but it looks like we had successful installs on quite a few. We had a lot of upgrades. We have a couple of brand new installs, and then we have one failure. I'm tempted to say that we should be okay with this failure. I don't think that's critical to what we're going to do today. So we're going to proceed, but something to think about. Okay, so what have we done? We've gone from a base install of CentOS. We used Yum to update all of the tools, software, whatever you want to call it, programs, to the latest version. And now we're going to go ahead and issue that curl command, right? The curl command is what actually goes out and gets a URL, gets the reply from that, right? So this is what's actually going to pull down the Conda installer. So let's go ahead and run that. Okay, so that was quick. Wow, that didn't take, that was so quick, it didn't even register any time here. But it does say that we received, right? Am I reading that right? Yeah, we did receive a package here. So if I go to, yep, there's the package. Remember, when we first looked at the files, this was completely empty. But now, that curl command went out and pulled this package. So this is the package that we're ready to, like this is where you would be like double clicking and executing it, right? But ChatGPT is telling us that this is the line we need. So let's go ahead and run that. So this is our license agreement. We're going to click on enter. We're going to type in yes to accept a license. It's telling us where it's going to install, which is perfectly fine to put it in Miniconda 3. And now we wait again. Okay, great. Okay, great. So a couple of things have happened. You can see here that it installed all of these packages, which is good for us. So for example, the one that jumps out at me is that it installed a newer version of Python, right? Remember before how I showed you it was like 3.9, which is not terrible, but not the latest version. It went up here and it upgraded it to Python 3.12. So now, when we use Python within Conda, it's going to go ahead and use 3.12 as our base install. You can change that, right? You can have different versions of Python in different environments, but it's good to know that that command in our server is set up to be able to reach out to these package managers, these package repos, and get the latest version of whatever we need, right? Because that means we can get the latest of pandas, the latest of Prophet, the latest of scikit-learn, right? All very important things. So this is good. I'm encouraged by this. I want to go ahead and add it to the shell. The shell file is what I was thinking about earlier. So the shell file, you can, yeah, I want to go ahead and do that. And then that's it. Thank you for installing Miniconda, right? We're done. And it says that it modified our shell file, right? Which is this one here. And that's how you're enabled to just use the Conda command in a quick way, right? So now it's saying we need to close and reopen our current shell, which I believe ChatGPT gave us the command for that. We already initialized Conda. Restart our shell is this here. Right? I think I missed the C. Bash RC. Yeah. So now we're going to restart our shell. And we're initialized. We're initialized on Conda, and we know this because of this. You see how now there is a default environment that we are always going to be taken to? We know that because it was at this, it's called the base environment. So that environment, or the name of the environment, will always be in front of our prompt. So you can see in the previous line, there was no environment. But now, because we did reactivate our shell, it gave us the Conda base environment to work from. So now we can actually access Conda commands because we're fully initialized. This is all great. I'm just walking through these steps to show that, you know, the intended results are happening. Right? Okay. Let's go back to our list. Now we have the virtual environment package, but now we want to replicate the virtual environment that we already have, right? Because we could sit here and reinstall Conda and Prophet and all, pandas and Prophet, but then it's like, wait a minute, what version were we using? Were we using Python 3.11 or 3.12? What was it? There's no need to do that. Conda lets you export your environment files and lets you save it and say, here is what your environment is. And now you can take that file and execute it on another server, and it'll recreate that exact same environment. In order to do that, we need to go back to our local server, our local instance, and say, create me a copy of that environment. Okay? So that means that for the next few steps, we're gonna minimize this window, and we're gonna bring up this window. It's still terminal, But this is our local install, right? And we can verify that by looking at the files we have. And this is the same files that we have on our Visual Studio Code, which means that we're working locally, right? So we could be going back to the manuals and checking conda commands, but let's let our employee handle that. And we're not looking to create it, actually. We're looking to export. Okay. That's good. I think that this is looking pretty reasonable. So what it's doing, it's asking us to activate the desired environment that we want to copy, which we already have because we're already working the terminal. And basically, this command here is the conda command that we need. We're using conda for an environment export. We're using no builds so that we can exclude any build information. And then we're naming the file. We're naming the file environment.yml. The YML is the format that conda uses to transfer different types of environments. And we'll take a peek at what it's like. But this here is, like the main item that we need. So we're going to do that by coming here. We already know we're in the alpha farming environment, which is our desired environment to replicate, right? Because this is where we've been doing all our work. So we're going to do this. And there was no additional prompt, right? It just created this file. So if we look at our listings again, there it is, environment.yml. And if we want to take a peek at it, the quickest way to do that is to go to Visual Studio Code, and you can see here, environment YML. And this is what's in it. This basically describes our environment. The name is Alpha Farming. These are the different repos that we pulled our libraries from. And then these are the different libraries that we need, along with the versions that we need. Because remember, it's really the versions that's going to trip you up here, right? So here we can remind ourselves and say, oh yeah, we were using Prophet 116, which may or may not be the latest version, but it's what works with our environment, right? You can also see that we're using Python 3.11. Well, we know that Conda installed 3.12. So we need to have this new environment use 3.11, right? Because that's where our program, our deliverable for our client works best, right? So that's why it's so convenient to have these environment files, because these environment files is how you actually can carry out those different shifts, those different exports to the different servers, and still help yourself ensure that it's going to work in the desired way, right? Okay, so what we need to do is we need to put this environment YML file onto our server and go from there, right? And execute it on that server, right? But here's the thing. We haven't established a way to have Visual Studio talk to that server. We haven't done that, right? So if we go to what ChatGPT told us, ChatGPT says here's the Linux equivalent to copy a file. And we could use this, right? You know, SCP is a standard way for you to copy a file over, right? But what we really need is we need our Visual Studio to talk to that server, because we're going to be using it for a lot more than this, right? So Visual Studio has SSH capabilities. So we're going to use SSH to connect our Visual Studio to our server. And that way we can do this environment file, but we can do a lot more files, right? Because we're going to need that. So let's walk through this. When it comes to these types of things, I like to manage it in a new window. So we're going to open up a brand new Visual Studio window. And this may not be the last one we need, but it's good enough for now. And what we're going to do is we're going to choose the connect to option, because that's what we want to do. We want to connect to a remote development space. So you can use it here, or it's also an icon that lives over here as Remote Explorer. So we're going to click on that. And you can see here that I already have a couple other servers. Because for me personally, I like keeping a couple servers around so I can bang code against them, you know, try different ideas. So you're not going to see that because it would be empty for you the first time you use it. So that's just reflecting some of the servers that I use or have used in the past. Some of these aren't active. But what we're going to do is we're going to add a new server, right? And if you see here, it's asking us what the SSH command. And that SSH command is very similar to what we used before, right? SSH username at location. So that's what we're going to do. So now it's going to be SSH root at, and then we're going to use the same IP address that we got from the previous DigitalOcean, right? Or previously from DigitalOcean. So that's the same command that we used in terminal, except that now we're using it in Visual Studio Code, right? And I want to put it in this file, my config file. Okay. So what is it? It's my 64227. Okay, so 64227 is our server. So I'm going to click on that, and I'm going to send that to a new window. And now it's opening the remote server, right? You can see that in the bottom corner. Let me expand this out. So it's opening the remote, and once again, it's asking us for the passphrase to our SSH key, right? Because in addition to having SSH security, I have locked my own local SSH key. So I'm going to enter my password. And there we go, we're done. We are now connected to our server. We're connected to remote, right? We're gonna go ahead and open a folder, and we're gonna go ahead and open the root folder. We're gonna go ahead and click on OK. We're gonna say we trust this folder. And now we're done. We now have a successful connection between Visual Studio Code and our server, that server that we just created. I think I might need to zoom that. Yeah. So this is the root folder on the 64227 server, which matches up here, 64227. And then we can further verify it by going to the terminal window and saying, show me what's in the root folder. Did I get? Yeah. So you can see that in the root folder, it matches up with the mini conda folder which is the same mini conda here. We're not seeing the hidden files because in Linux, all these dot files are usually hidden files. So we're not going to see those, but we can verify that this file and folder listing is the same as what we're seeing up here. So we're essentially done with this portion. We now have a way to talk from our local machine to the provisioned Linux server. We could have done that with the way ChatGPT said via SCP, but we know we want to move a lot of different files, maybe make some changes, so on and so forth, right? So I think this gives us a little bit of an easier way to talk to that server. So let me get rid of some of these extra windows because we're not going to need every single window we opened. Okay. All right, so I'm kind of layering two Visual Studio windows here, right? You can see here, we have the environment YML file. And then we have our, quote unquote blank production server because there's nothing up there on that server, right? So now we got to move this file to this server, or at least copy it, because we need to execute it on that server, not locally, right? We created it locally, but the execution is going to happen on the remote server. So this is where things get a little hairy, but I think that we can just drag and drop across the two. Oops, I got to bring up the other one. Let me put these side by side. Okay, so if we take this, all we did was just drag and drop, right? This is the left side is local, the right side is remote. And all we did was just drag and drop. And now if we go back to our terminal, there it is, environment.yml. That's the file we just moved over. So that's what we now need to execute in order to make sure that this environment file is used to create the environment on the remote server. Okay? So back to our employee. Now, I'm asking this question again, to develop our prompting skills, but I'm pretty sure I know the command already. It's going to be a conda create command that references this YML file. But let's see what ChatGPT comes up with. Oh, you know what? It was already there. Yep, conda environment create from the -f indicates a file, and then environment.yml is the file name that we created, right? So that command looks reasonable to me. And again, we are executing this on the remote server, not locally, because locally it already exists, right? We need it on the remote server. So I'm going to say that that's okay. Environment.yml is the file name. Let's execute this. Okay, great. So now it knows what channels we're pulling from, and it knows the packages that we need. Did that finish? Collecting package metadata repo data.json killed. That is interesting. I don't think I've ever seen that. I don't think it actually created it. But we can verify that. We can verify by trying to instantiate it, right? Okay, environment name not found, which makes sense. Let's see if it created anything. Nope, it didn't create anything. The only thing we have is the base environment. Oh, you know what it could be? It could be because we are in an environment ourselves. It's possible that we need to deactivate the base environment and then run it from a prompt that's not within any environment. Let me try that. Okay, so I issued a conda deactivate command because that's what's going to say, hey, I no longer want to work in the base environment. I want to work within a non-conda virtual environment. Now let's try running that same command. The create command of the environment file, I mean. Same result. Interesting. All right. Let's see what ChatGPT has to say about that error. Oh, wow. The server ran out of memory during the package resolution process? Wow. Okay, that's interesting. Using the no dependencies flag to limit dependency resolution? Okay. We could use a verbose mode to specific problems causing the failure. Consider installing the packages incrementally. That could work, but that kind of defeats the purpose of what we're doing, right? I want to try the debug. Let's see if we can get a little bit more insight on that. Wow, that gave us a lot of information. So it looks like picking the cheapest server for simplicity is kind of working against us here, because it says that it's related to memory allocation, which makes sense. So let's just establish something, right? This is typically an error that would not happen in a larger environment. This is happening because of, what was it? I think it was 512 megabytes of memory that was chosen, right? In the cheapest server possible. So this is kind of working a little bit against us here. That's basically what we're running into, right? According to ChatGPT, this is the fundamental cause is that the server itself is running out of memory when it's trying to get all the dependencies. So we could do the package resolution with no dependencies and then install the dependencies manually. I can't remember if dependencies are located in the, they are, okay. So dependencies are located in the YML file. So we could choose to install these by themselves, which isn't the worst thing in the world, but kind of defeats the purpose. But for the purposes of moving us along today, I think we're going to have to do that. So what we're going to do is we're going to use the no dependencies option, which is basically going to ignore all of this, but still help us create the environment itself. I think we should still be okay with that. The other option is to upgrade to a larger server, but I'm not sure if I want to go through that for the purposes of today. Actually, that is another option, isn't it? Let me just look at that real quick. Yeah, there is an upsize option. We could resize it to, right now we're on a regular one, 512 megabytes of memory, which is what's working against us. You know, I'm gonna kill this server after we're done anyways. So why don't we do that? You know what, guys? Let's do that, because I really want to get the full impact of doing this all automatically, right? Because you wouldn't do individual dependency installs. So I'm going to blow away this server once this session's over anyways. So let's just go ahead and do that. We're going to pick one of the 2 gigabyte options. It's going to cost me 2 cents per hour. Oh, actually, there's more. There's a 4 gigabyte. There's an 8 gigabyte. Let's do an 8 gigabyte on Intel. Oh, it's an AMD. That should be okay. Okay, so let's choose that. Why is that not up? Why is that not? You must turn off your droplet before resizing. Okay, let's do that. All right, so we've closed that terminal connection. We're going to turn off the server, resize it, and go from there. So sorry about that, guys. All right, we've shut it off. We're going for the premium AMD 8 gigabytes. Resize it. Probably going to take a minute or two. And then go from there. Tariq over on Kick. Hello, how are you? Welcome. I think it's your first time, so glad to have you here. Tariq, we're in the middle of doing some Conda work to simulate pushing out code from our local server to a remote server, which could be like a team server, a production server, whatever. So yeah, feel free to follow along or ask questions. Happy to help. Right now we're upsizing one of our droplets. We can see the progress. It's almost done. Did that finish? Okay, droplet has been resized, which is great. So now if we go ahead and turn it back on. Now, I don't think we should see any significant difference. Our same files will be there. We're going to run the same commands. This is all just updating our virtual server to have more power. That's all it is. So it looks like it's on. So we're going to go back to the exact same terminal window, except now we're back to being local, right? These are my local directories. So we're going to use that exact same command, the SSH, or the root user at our server IP address. Gonna put in my passphrase. Again, this isn't a server password. This is my key password. All right. So now we're back. We're gonna deactivate the base environment again. So now we're back to just a plain Linux prompt, and we're gonna run the exact same command that we did before. We shouldn't run into issues this time. So let's review. Conda, environment, create from a file, and the file is called environment.yml, which we already verified exists. It's the same file we moved from our local server to the remote server. So now it's going through that same step that was failing before, but what it's doing is collecting all the information from all the dependencies we need, and this is where it was running out of memory. We shouldn't have that issue anymore. We upped the memory by what, 16x, I think is what it would be. But now we wait. We wait for Conda to do its thing. And there we go. That's starting the installs. All right. So when you see this, when you see the instructions to go ahead and activate an environment, you're basically done. Okay. So just to kind of put a finer point on different environments, remember that when we first logged into this machine, it was we looked at Python and it was Python 3.9. When we installed Conda in the base environment installed 3.12. And then we know from our environment file, right? We know that we're using Python, we're using Python 3.11, right? These are exactly the types of issues that environments can help you with. So let's prove that out. So here we have no environment. We ask for Python, and you can see that the OS is using Python 3.9.2. Not the worst thing in the world, but maybe it doesn't meet your needs, right? So we're going to exit out of that. Now we're going to activate the base environment and look at Python in there. Python here is Python 3.12.7. Whole different version of Python, right? Lots of changes between 0.9 and 0.12. I think 3.10 was like a major release for Python, right? Or a mini release for Python, right? But now we can use Python 3.12 in this environment, right? But again, that's too much. We only need 3.11 for our project, right? So now I'm going to deactivate this environment. And I'm going to activate our new environment, the environment we just created programmatically. Conda activate. Oh, come on, Dennis. Alpha farming. So that's our alpha farming environment. And now we can see that in here, it's Python 3.11.1. This is how you prevent those types of collisions. If you didn't have Conda, that means all your work would have to be done on Python 3.9 because that's what the OS does. If you are working in the base environment of Conda, you'd have to be using 3.12. But we don't want that, so we create our own environment, and that's how we're able to use Python 3.11 that exactly matches what we did locally. So now we've greatly reduced the possibility that when we go from our local install, code-wise, when we go from our local install to a remote server, of there being like versioning and library and all these collision issues because the environments on the two machines, even though they're completely separate from each other, are exactly the same, right? So that's a huge win, huge win. All right, so let's exit out of this. Okay. Oh, whoops, I didn't. Oh, come on, Dennis. Okay. All right. Okay. So we have an environment. It's exactly the way it is on our local machine. I think it's time to start moving some files, right? Let's go back to our Visual Studio. We're going to close this out because we're done with environments for now. So again, this side, the right side, the left side is our local. The right side is our historical, right? Oh, I got to put in my passphrase again because we restarted the server, so the connection was lost. Makes sense. We had to go through the reload here, guys, because of the reboot of the server, right? When we upsized it, we had to shut it off, on and off. Okay, so now we're back. This is our remote server. That was our environment YML file. But we're kind of done with that file for now, right? We could actually delete it at this point. It's not a dependency or anything. It's just like a general guide. What we do need is we need the time series prediction file. Because if you remember, we agreed that that's our final deliverable, right? So let's go ahead and move that over. Oh, right. So let's start moving this file over. Okay. So now if I go here, there it is, time series prediction. That's our code file. That file represents all of the hard work we've done in all the previous installments of this series, right? Lots happening in that file. It's our deliverable. It's what we can ship to the client. It's what gets us paid, right? Like lots happening here, right? Okay. So participation time in the chat. Python time series prediction .py. What is the result of me running this command? What result do you expect if I go ahead and execute Python time series prediction .py? Let me know in the chat. I'm going to give you guys a couple of minutes. I need to take a drink of water. So let me know what's going to happen when I press enter on this file. Let me know. Okay, Denelson, thanks for volunteering. Denelson says, it will be an output for this past week and we'll need to retrain the model again with the new data. Okay. Okay. Anybody else? Any other questions? Again, the question, or any other answers, I should say. The question in front of the chat is what's going to happen when I click enter to run time series prediction.py? Naaman says, does this file have the ingestion and other requirements like training code linked to it? If yes, then they will start the whole project building process. Okay. All right, so two completely different answers there, right? You're free to give another answer, but I know sometimes people are too shy. So you can say, I agree with Denelson, or I agree with Naaman, give up a new answer, whatever you'd like. But let's get a couple more answers in here. What do you guys think? The question is, what's gonna happen when I run time series prediction.py? You can see my entire listing there, right? This is everything I have, right? We have our mini conda, we have environment, and we also successfully moved over time series prediction.py, which Denelson, is correctly remembering. It's the file we worked on last week. But what's going to happen? What's going to happen here? Any other answers? Last call for answers. Give you guys another minute here. What do you guys think? Anybody else with an answer? Naaman is adding to his answer, but this is a new server and doesn't have the file, so maybe just the training may start. Okay. Does anybody agree with Naaman, or maybe you agree with Denelson? What do you guys think? It's also totally okay to say, I don't know, right? I don't know is a valid answer, right? If you're a scientist, there is absolutely no shame in saying, hey, I don't know. I don't have enough information here, right? So that's also a valid answer. But last call for answers. Lakshmi says, I don't know. Okay. Thank you, Lakshmi. I appreciate that. It's totally okay to know your limitations and know that you don't really know what's coming up. Okay. So, the closest answer, I think Naaman is on the right track here. Because my full expectation is that this is going to give us an error. Right? Because remember that we have a couple of dependencies here. Not library dependencies, not Python dependencies. But didn't we have a saved model file? We did, right? Because remember, this is only 60 lines of code. And this is where we're loading the model, right? So there's a dependency there. There's a dependency on this model 9 pickle file. Because we know that model 9 was our champion in our process, right? So there's a pretty significant dependency there. We haven't transferred over the pickle file. In addition to that, look, there's a path there too. Does this path exist on our server? It doesn't, right? We haven't created it yet. So the file shouldn't run because we haven't given it enough information. In addition to that, we put the time series prediction file in the root of our server, but locally, it's not in the root. We put it in its own predictions folder, right? So this is what I mean, where we go back to we need to replicate the files and folders that we already have. We haven't done that. So all these paths that are built into this file are not valid because they don't exist on the new server, right? So we need to do that. That's part of the next steps that we need to follow. Okay? Is everybody clear on that? Super important because you can run into problems with this. Said another way, the environment file is not the only thing you need to replicate locally. The environment file lets you work with Python and the libraries and things like that. But you also need to look at it from just like a file and folders perspective to say, I need these folders, they need to reference these paths, the files need to be called this, this, and this, so on and so forth, right? So keep that in mind. All right, so we're gonna go ahead and move the modeling folder because we know our model's in there, right? I'm gonna go ahead and move the entire folder over because I'm gonna kill this server anyways. But generally speaking, you only wanna move over the files you need. So we really only need modeling, save models, and then so on, right? But we're gonna go ahead and move the whole thing over just for, simplicity. So we're gonna do that. We're gonna put it here. And yes, I wanna copy over the folder. So now we have here, that's our modeling folder. And now I wanna also move over the predictions folder to keep it all the same. I'm gonna move this over. I do wanna copy the whole folder. So predictions is now there. So now we have predictions. We have our time series prediction and we have our modeling folder, and the modeling folder has saved models. And then just to not confuse ourselves, we're going to go ahead and delete this file that we created in the root. We're going to delete that. Okay. So let's go back to our terminal. Let's see what our files look like. Okay. So now we have a modeling folder and a predictions folder. If you look at this file here, does this path now exist on our remote server? Yeah, it does, right? Because if we go to modeling, there'll be a save models folder there, and we're good to go, right? Now we can't run this command because there is no longer a Python time series prediction file there, right? We have to go into the predictions folder. So there is our time series prediction file, as it should be, right? Because now we've replicated it how we have it on local, right? So this is good. So now we can run that same command. Okay, what do you guys think of that? Doesn't that look a whole lot more like the output we were getting last week? Right? This is basically where we left this last week, isn't it? What do you guys think? If we go back to our presentation, it kind of feels like we just ran that smoke test, right? By executing that file, that essentially was our smoke test. Because this is our desired result. This is what our program is designed to tell you, the date and the projected price. And we did that just by moving over two files. The saved model file, right, the pickle file, and the predictions, time series predictions Python. So now we are assured that when we run this, it's going to run the same. And in fact, let's prove that out. So if I minimize this, I should go back to local. Yep, so this is my local, right? I'm back to my local machine in this terminal. So if I go to CD predictions, and I run it here, guess what? Same result, right? You guys see that? Left side over here, this is local. Right side is our server. But guess what? We're done. We're done. That's the smoke test to show a successful deployment. That's what you want, right? You want the same thing that you're working locally to work on another server. So for example, if our server, our remote server, was our UAT server or our testing server, this is where you send your stakeholders. And you say, hey, go check it out. We deployed it over here for your approval, for your sign off. Meanwhile, you can still continue to work locally on your development machine. You know, maybe you want to fine tune some things or whatever. And you're not affecting both of those, right? That's a positive thing, right? So this basically validates the whole exercise. This is how you prove that the deployment is working as intended. You use the same environment file. We didn't run into any dependency issues when we ran the code, because that's another issue you could run into, right? Where it would tell you that, oh, I need Python 3.1.1 and you've installed 3.1.0, right? But we didn't do that because we use an environment file. We can verify that we're using identical environments. They're both called alpha farming, created from the same YML file, right? So this is essentially the smoke test that we needed. So good, we got through that. Before we leave this, before we wrap up, I do want to point out a couple of things. So if we go back to our Visual Studio Code, remember that we were working with two instances, right? This is our local, and then this is our remote server. That's why they look a little bit different. But a couple things I want to point out here. Couple things to note here. One, remember this environment YML file that we were working with? This becomes an increasingly important file for you. Because remember how I said that you could have multiple deployments, right? You can go from your local to your team server to your UAT, even to your staging and then your production. Well, guess what? You're going to be using the same environment YML file. So what you'll find is that these YML files become part of your deliverable to your internal IT folks, not your client, but to your IT folks. So when your IT team says, okay, send me the stuff for the production environment because you data science team don't have access to those servers, only we do. You need to send them this YML file. The smarter ones will ask you for it because they know they know Conda pretty well, right? But in most cases, you're going to have to kind of force this upon them and say, hey, this is what I need. Naaman says, so YML file is similar to requirements.txt. Yes, Naaman. If you want to think of it that way, yes. The difference is that requirements.txt isn't always executable, right? The requirements.txt is usually like a reference, like a README, whereas a YML, you can actually like execute it in Conda, and Conda will read it and do the installs for you, right? Requirements.txt doesn't always do that, right? But you're thinking along the right lines. But yeah, so remember, this now becomes pretty critical to your overall deployment, right? Or in some cases, you would hand it over to the client, right? Maybe the client has their own servers. They're savvy enough to have their own servers. You would tell them this. You would say, hey, can you and I standardize on this environment file? So anytime I ship you something, we know it's going to work because we have identical environments. All right? Super critical for you guys to remember that. Second critical thing. Remember that we now have a similar file structure, right? We have the modeling folder with our saved models. We also have our prediction that has our time series prediction. Well, it's super convenient to have that connection because remember, we're connecting to the server 64227. It's super convenient to have it here because I can see my code, right? But I can also modify my code on here. Is that good? Is that bad? Well, if I modify my code on here, it's not gonna modify my development code, right? I would have two code bases that are out of sync, because I can make, changes on this code, but now this is essentially hot code because it's on a server that other people can access, right? So I'm saying that to illustrate why I decided to bring up source control at this time. We haven't talked about it. We haven't needed it up until this point, right? But now, all of a sudden, the source control kind of becomes important, right? Because you don't want to have two code bases that are out of sync. I mean, that's kind of bad, right? Well, I mean, not kind of bad. It is bad. Because you always want to make sure that your development environment reflects what's up there so that you're making changes that are on current code, right? So again, the point there is, this is why source control becomes even more prominent at this stage. You could be using it locally. There's nothing wrong with that, right? Some people would say it's essential. I don't share that view. I'm not someone who feels that every single little piece of my experimentation needs to be in source controlled. But this illustrates why it becomes so much more important, because you do not want those code bases to get out of sync. That's bad. So that's why, I decided to introduce it in this class, because it becomes important. All right. Okay. That covers everything that I wanted to do today. If you have any questions, please put them in the chat, or something's not clear, put them in the chat. But this is how we get from our local machine to actually working on a brand new server. This is how you're going to find things being done in some of the environments that you'll be working in. I'm showing you a compressed version, right? Because of the live streaming and all that. Some of these topics do go a lot deeper than this, but this should give you a sense for that. Another thing you could think about is we did actually very, very little data science specific items today, right? Because yes, we used Conda and environments, but that's a Python thing. That's not a data science thing. You could just be a traditional Python developer and still use Conda, right? The code we moved over could have been any type of code. It didn't have to be modeling or predictions code. We would have had the same issues with the pathing, with the library dependencies, right? It just so happens we have data science libraries in there, but this could have been for anything. So remember that in some of my previous content, I have told you guys that the further along you get in a data science project, the more it converges on being like a traditional software project, right? Like what we could have done right now, we could have said that we were a DevOps team or a developer team, and we were pushing out a new feature to some traditional program. It just so happens we're a data science team, right? But like this, if you extract the generic information out of it, any development team could have used this today. Because again, the further you get along, the further you get to those save models, those programs that you write for those save models, you become just like any other library. Because look at this code. This code, it's in its own class. You could be calling this class from any number of other programs. We happen to be calling it within this harness that we have to view our results, but you could be calling this from anything else. You could be calling this from a mobile app, from a web page, whatever. It doesn't matter. Like at this point, stock price predictor is a class just like any other class that you would use in any other library. So when I tell you guys, it doesn't matter. I've walked into meetings where you can deploy things and you could tell them, we did this with an algorithm or we did it with a room full of monkeys. They don't care. You're calling a very generic class and you're getting some results back, right? You as the data science team know the different machinations that are happening to give those results. But to the people receiving it, it's just another library, right? Written by some other team. And that team could have been a development team or it could have been a data science team. Who knows? They don't care. Doesn't matter, right? It just becomes more generic at some point. Okay. Michael says, thanks for the class, Dennis. A lot to unpack today. Related to that, Osama says, I believe I should watch this episode again. Yeah, you know what, guys? I fully concede that we covered a lot of ground today. If this is your first time seeing Conda or seeing environments, it's a lot to take in. I can appreciate that. I can empathize with that, right? So if you guys want to send me some feedback, if you want to say, hey, Dennis, can we have a dedicated Conda class or something else? Or maybe you guys want to do a Linux class too, right? You know, maybe some of you got lost on the servers. That's okay. Let me know. Give me some feedback if that's what you guys think. We did cover a lot. But really, again, the meta item that I would like for you guys to walk away with is the realization that this could have been by any Python team. We don't have to be a data science team to go through the same items, right? You know, and by the way, I said that because I remembered, you know, Naaman's earlier point where he asked about requirements.txt. If you guys don't know what that is, that's a typical file you would find by a developer writing another, like, you know, typically a Windows program. But that program could be anything, right? It wouldn't have to be a data science program, right? So it's kind of like one of those, you know, vice versa types of things where you could have been anybody writing this, right? Naaman says it was a great session. Thank you, Naaman. Appreciate that feedback. Rex says, yes, I'd love to explore the software engineering side of data science. Well, this is part of it, Rex, right? This is a big part of that. The next part that I would probably extend this to, if you really wanted to talk about that, Rex, is designing your own API. How do you design an API that uses, that calls stock price predictor, right? Because we know that this is what uses our library, our save model. But now, can you add an API layer on top of that to use our class stock price predictor? Why would you want to do that? Well, because in modern software engineering, you want to create the API layer because applications are consumed by so many different things. Like I said, you could be sending it to a mobile app. You could be sending it to a web page. You could be selling that data, right? You could be a data provider. Maybe you want to sell this data. So you'd want to keep a generic API endpoint for other applications to connect to. Or maybe your program will be used by Salesforce, or it'll be used by SAP, like, you know, like as an integration, I mean, right? So that's the next step up, to create a generic API layer so that you always have this endpoint out there that's listening and can give information from your algorithm. That's kind of like the next level of abstraction. Because again, when somebody consumes data from that API endpoint, they don't care if it's data science. At that point, you've even become language agnostic, right? APIs are powerful because any language can access them. Well, REST APIs are powerful because any language can access them. Like, it literally doesn't matter to you as the API creator. So Rex, if that sounds interesting, send me some feedback later. You know how to reach me. We could definitely have a session on that. But yeah, at that point, that's like, that conversation is like 90% software engineering, 10% data science. But, you know, if you guys are interested in that, maybe we could talk about that. All right, guys. Thanks so much for sticking in there with me. We went more than 2.5 hours, so that's a long session. Really appreciate all of you. Lots of good stuff covered today. Like I said, I'm willing to concede that there were some more complex topics today. So if you're lost on something, let me know, okay? But please, lots happening in the world. Please take care of yourselves, take care of your families, and I'll catch you guys next time.